so yesterday I showed you these, but like I said, they don't make sense unless you see it played into action. So here's the function f of x equals 9 to square root of x, and we're asked to find the derivative of that. Now, in order to find the derivative, let's go through a simpler one for right now. So you have 2 of x squared plus 3x plus 1. So the way you find the derivative is you're going to take the exponent and multiply it by the numerator here. So it's going to give you 4x, and then you're going to subtract the exponent 2 subtracted by 1. In any case, it's going to be subtracted by 1. If you have 3x cubed, you're going to subtract 1, you're going to get 2. So 2 minus 1 is 1. It's the same thing as leaving it as 4x. Now if you have 3x to, let's just say it's to the power of 1. So you're going to move it over. 3 times 1 is 3. And then since it's only x, 1 minus 1 is 0. The x cancels out, so you just leave it as 3. When you have 1 without any x, it's not going to value to anything, it's just going to cancel out as well. So the derivative of, let's call it f of x for this, or f of x for this situation, is going to be this one. So same concept over here, but it looks ugly when you have it this way. So how can we rewrite it in order to make it look pretty? So we're going to go over to look for one that looks kind of like that. And we have square root of a. So you can rewrite it as this. So you're going to get 9x to the 1/2. And so that makes it a little easier. You're going to multiply this times the 9. You're going to get, you can write it as 9 over 1, which is the same thing as 9, times the 1/2 x. And then you still have the 1/2 up here, right? So you're going to subtract it by 1. Another way to rewrite 1 to make it fit is 2 over 2. So therefore, you're going to end up with 9 over 2 x negative 1 over 2. But however, when you have a negative in the exponent, it's going to make this go to the bottom of the fraction. So that's just a rule. So you're going to get 9 over 2 x to the 1/2. And if we go back to the rule over here, it goes vice versa. You can go from this to this. So you have x to the 1/2, which you can rewrite as x square root of x. So you're going to end up with 9 over 2 square root of x in the denominator, and that is the derivative of f prime of x, going from here to here. So that's just what this is used for. It's just to rewrite it so that whenever we get an ugly problem, we can simplify it and make it divisible.